So 8.3 talks about geometric sequences. Because I didn't do paper notes for arithmetic, I kind of put a little bit of extra information on these ones. You don't have to print this off, but I am going to attach this blank document in case you want to have your notes all in one place. So recall an arithmetic or arithmetic sequence consists of a list of numbers with a common difference, which means the same thing is getting added each time. And if you want to think about that formula, because we know difference to mean subtraction, and it does, but in the opposite order, whatever. The same thing is getting added each time. In a geometric sequence, it consists of a list of numbers with a common ratio, meaning the same thing is getting multiplied each time. Or if you think about it backwards as division, that's where the ratio idea comes from. So when they say determine whether each sequence is arithmetic or geometric, they're just saying, is the same thing getting consistently added, or is the same thing getting consistently multiplied? And keep in mind that you can add a negative number, or you can multiply by a fraction or decimal. So letter A, going from 6 to 12 to 18 to 24, since we're adding 6 every time, this is arithmetic. And when they say what is the common difference, the common difference is 6, because that's what we're adding each time. So when I look at letter B, I'm saying, what are they multiplying by each time? 256 times what gives me 64? That's what I'm trying to figure out. What am I consistently multiplying? Or 16 times what gives me 4? It has to be the same thing with any pairs of numbers. So if I take 64 divided by 256, or if I take 4 divided by 16, this is a geometric, because the same thing is getting multiplied each time. And I would say that the common ratio is either 0.25 or 1/4. I guess be on the lookout if they ask for fraction or decimal, but it doesn't matter between the two. Okay, so it says note the graphs of arithmetic sequences. Oh, I meant to open this up. Okay, let's go exploring here. So I don't think I posted it on the Google Classroom yet. I might just redo this video if this takes too long. There it is. Oh, wonderful. Okay, so the graphs of arithmetic and geometric sequences. Okay, open. Just to visualize what's going on here, arithmetic sequences, if the same thing is getting added each time, is going to, in general, follow a straight line, either up or down, depending on what you're adding or subtracting. And then geometric sequences, because the same thing is getting multiplied each time, takes more of that exponential shape. Or it might go down, but it's still got that kind of curve to it. That's all that talks about in that paragraph there. It says, recall the formula for finding the nth term of an arithmetic sequence from section 8.2 is listed right there. Since repeated addition is equivalent to multiplication, it makes sense that the common difference, represented D, is getting multiplied by the term number, even though arithmetic is about what's getting added. This is new here, the formula for finding the nth term of a geometric sequence with first term A sub 1 and common ratio R, so what are they multiplying each time, is written there. So A sub n equals A sub 1 times R to the n minus 1 power, because if I'm looking at up here, if I'm multiplying by 0.25 times 0.25 times 0.25, that can be rewritten as an exponent. So it says write a rule for the nth term of each sequence, and then find A sub 8, which means what is the 8th term. So instead of having to look at this and go, okay, what are they multiplying by each time? They're multiplying by 3 each time. I don't have to go multiply 135 by 3, and then multiply my half by 3, and then multiply my half by 3. I can write a formula and then use my formula. So I need to know the first term, and I need to know the common ratio. So in the case for letter A, the first term is 5, and the common ratio is 3. So I'm going to write the equation A sub n equals 5 times 3 to the n minus 1. And it's very important that you do not make that 15 to the n minus 1. the 3 is the only part of that that's getting raised to the exponent. So it stays separate 5 times 3 to the n minus 1. And then if they want to know what the 8th term is, well, plug in 8 for n. So I'm going to be taking 5 times 3 to the 8 minus 1, which is 7. So again, it's not 15 to the 7th. It's 3 to the 7th power, which I'm going to use my calculator. It's 2187. And then when I multiply by 5, I get 10,935 for the 8th term. And then letter B, I have to decide what are they multiplying by each time, because the first term, hopefully, obviously, not obviously, the first term is 88. So then I'm saying what is the common ratio is what's getting multiplied each time. So what do you multiply 88 by to get negative 44? You can certainly figure this out without having to set up a formula here, but I just want you to understand what we're asking for. So negative 44 over 88 simplifies to be negative 0.5 or negative 1/2. And then I personally don't care fraction or decimal as long as you don't have to round the decimal. But I would pay attention. I think you have IXL to what they want. So the formula up here, a sub n equals a sub 1, which is 88, times, I'm just going to put it in parentheses like this because it's a fraction. I could put the multiplication sign, but negative 1/2 to the n minus 1. So that right there is the formula. Note that it's not negative 44 to the power of the fraction. The multiplied numbers stay separate. So then when I plug in an 8, I'm taking 88 times negative 1/2 to the 8 minus 1, which is 7. So I'm going to take negative 0.5 or negative 1/2 in parentheses like that to the 7th power, and it is still negative multiplied by 88. I get negative 0.6875, and then my calculator, if I go to math and go to fraction, it'll change it to the fraction for me, just depending on the format that they want. But there's nothing wrong with the decimal version because I didn't have to round.